6.4 Evaluation and feedback for future actions. Using notational analysis, we can see that Charlie's team covered a larger distance of 1,750 metres compared to Aaron's team, which covered 1,625 metres, which would suggest that Charlie's team worked harder. Aaron's team had a 3.25 average of 2 points attempted, whereas Charlie's team got 1.4 attempts on average, which would suggest that Aaron's team was stronger in their shooting. However, of the 3.25 attempted by Aaron's team, only 1 on average went in the basket. Charlie's team converted 0.8 of their 1.4 attempts into successful shots, which would suggest that they are better at scoring. Compared to the average of the entire group, 2.78, Aaron's team were above the average on their 2 points attempted, but Charlie's team were below average. Within Aaron's team, according to notational analysis, Aaron was the strongest player. He covered the most distance, 2,000 metres. He attempted the most 2-pointers, 5, and 3-pointers, 3. His overall score was 10, the best in the team, compared to the second best player, Charles P., who scored 6. Within Charlie's team, according to notational analysis, Charlie was second in metres covered. He was the second highest scorer on 2 and 3-pointers, scoring a total of 4 points. Obe scored 5. Charlie got 1 defensive rebound, which was the second best in the team. According to notational analysis, Charlie would appear to be the second best player in his team. Analysis of the notational data shows that Aaron attempted more 2-pointers but scored the same number as Charlie. This would suggest that Charlie is the better player because he has 100% success rate. However, it does show that Aaron was more involved in the game, which is what you need to be a power forward. Aaron attempted more 3-pointers, 3, and scored 2, whereas Charlie attempted 1 and scored 0. This would suggest that Aaron is the stronger attacking player. Both Aaron and Charlie had a 50% success rate with their free throws, but whereas Aaron attempted 4 and scored 2, Charlie attempted 2 and scored 1. Aaron would therefore seem to be the better player because he attempted more and scored more, even though they had the same percentage success rate. Aaron made 2 steals and Charlie made 1. Neither player made an offensive rebound, but Charlie achieved 1 defensive rebound. According to the data, Aaron wins 3 of the performance criteria categories, and Charlie wins 2. This would suggest that Aaron is the better power forward and should be chosen. Also, the categories that Aaron wins, he does so very clearly, which can easily be seen when looking at the graphs. According to notational analysis, Aaron's strengths is in his attacking play. For instance, he attempts 5 2-pointers, which is the 3rd highest in the players of all the teams. He scores the joint second highest out of any player in all of the teams. He is the second most successful player attempting and scoring free throws. He attempts 4 and scores 2. Only Obe is more successful, attempting and scoring 3. On 3-pointers attempted and made, Aaron is second only to Ellis. Aaron attempts 3 and scores 2. Ellis attempts 5 and scores 3. Aaron covers 2,000 metres, which is the second highest of all the players, which would suggest that he worked hard. Even though Aaron is a very capable attacking player, he could further improve his shot accuracy. Aaron's weakness as a player is in his defensive play. Aaron made 2 steals, which is 1 more than the mean average, so he did reasonably well with his steals. However, he underperformed with rebounds compared to his game as a whole. The mean average for defensive rebounds is 3, and for offensive rebound is 2, but Aaron made 0 defensive or offensive rebounds. Using notational analysis, I have identified defensive play as the main weakness in Aaron's game. In order to improve his defensive play, Aaron is going to target rebounds for the next 4 matches he plays. In the first match, he will achieve at least 1 offensive and 1 defensive rebound, building up to 3 of each in match 3. This meets the SMART target because it is specific to the weakness in his game, it is measurable because it can be monitored by his coach. It's achievable because Aaron is a capable player and should be able to improve his rebound success by focused effort. It is realistic because it isn't too hard for him. It is time-bound to the next 4 matches. By the end of the 4 matches, it should be a normal part of his game. A second weakness is Aaron's scoring success. In order to improve his scoring rate, I recommend that he spends the last 10 minutes of every training session for the next 2 weeks practicing 2 and 3 pointers. He meets the SMART target because it is specific to the weakness in his game, it is measurable because it can be monitored by his coach, it is achievable because Aaron is a capable player, it is realistic because it isn't too hard for him, it is time bound to the next 2 weeks. Aaron's score rate should improve in the next 2 weeks after doing the drills. When comparing the whole class's impulse and jump height, there was a strong positive correlation between how large the impulse was and how high the participants jumped. The R value was 0.87 between -1 and +1, which shows that there was a strong positive correlation because 0.87 is close to 1. This means that how large someone's impulse is determines how high they can jump. Also, the p-value was 0, which suggests that the data was reliable and valid. This means that the correlation is true because there was one small anomaly, data 13, measure 1, 313, and measure 2, 1.37, which might have slightly affected the trend of the graph, but will not have had a dramatic impact. Between the height and time in the air, there is a moderately positive correlation because the R value is 0.46, which is 0.54 off of 1. This means that there is a possibility that if you're taller, then you have a longer time in the air, but there is also a possibility that height is not linked to time in the air. The p-value is 0.057. This means that the result is probably down to luck because it is over 0.05, which suggests that the data isn't reliable or valid. A reason for this could be because there is one large anomaly which does alter the trend of the graph, data 15, measure 2, 830. It is not surprising that a strong link cannot be made between height and time in the air, because jumping relies on powerful leg muscles, which does not depend on how tall you are. However, when you think about sports such as high jump, the athletes are usually tall and thin. The whole class's mass compared to their max force is not directly linked because the R value is 0.47, which shows that there is a moderately positive correlation because 0.47 is almost halfway to 1, which suggests that possibly a greater mass results in a larger force. Sometimes, depending on the mass, the max force is larger, but not every time. The p-value is 0.048, which means that the data isn't very reliable because it is just under 0.05. One reason why the data is unreliable is because of a large anomaly in the data, data 17, measure 2, 3727.1, for their max force, which is not possible. Therefore, there must be an anomaly in the data which affects the overall data and the trend of the graph. If the large anomaly was to be removed from the data, there is a possibility that a correlation could be shown between mass and force. Charlie I is 180 centimetres tall, which is 3.8 centimetres over the average of the class, whereas Aaron was only 173 centimetres, which is 4.2 centimetres below the average and 7 centimetres smaller than Charlie. However, even though Charlie is taller than Aaron, Charlie's mass is 63.2 kilograms, whereas Aaron is 64.3 kilograms. Compared to the mean of the whole group, both of the players are below the average. This data shows that Aaron might have a denser muscle mass, which can mean that he has a greater impulse, but Charlie has 188 newtons of propulsion, and Aaron has only 174 newtons of propulsion. Charlie is just over the mean of the group, whereas Aaron is below the mean. Finally, Charlie has a larger max force, 1,573 newtons, whereas Aaron has a smaller max force, 1,561 newtons. Charlie and Aaron are both below the group average, but Will's data seems to be an anomaly, which will affect the average of the entire group, because it is very different to all the other data. Charlie has a larger force, and this could be a reason why Charlie had more time in the air. Charlie was above the average for time in the air, 617 milliseconds, but Aaron got 523 milliseconds, which was below the average. Charlie jumps higher on all three jumps. One reason why Charlie could be better than Aaron at jumping could be because Charlie is 180 centimetres tall, whereas Aaron is 173 centimetres tall. When you think of athletes who are good at jumping, for instance high jumpers, they are usually tall and thin. However, our data does not support this theory because we did not find a correlation between height and time in the air. The data also shows that Charlie has a greater max force output than Aaron, which might mean that Charlie has a better muscle to weight ratio and is therefore stronger when it comes to lifting his own body weight. Charlie, the less experienced player, has a higher propulsion impulse on all of the jumps. On the 45-degree jump, Charlie got 172 newtons of propulsion, whereas Aaron got 154 newtons of propulsion. Charlie is more able at jumping because he was 18 newtons more powerful than Aaron. Charlie jumped higher on the 45 and 90-degree jumps, and this could have been because Aaron held an isometric contraction for a long period of time before he jumped, because the angle took a long time to measure, and this might have affected the results. Also, Charlie didn't stay at 90 or 45 degrees, so he would have had an advantage. The stretch-shorten cycle is a protective mechanism to stop us from tearing tendons. When the muscle stretches, a message is sent through the sensory neuron to the spine, which sends a message back to the muscle via the motor neuron to contract in order to protect the tendons. The message bypasses the brain altogether, so the message is automatic and happens extremely quickly. The stretch-shorten cycle is used in sports performance to increase power. By doing powerlifting and plyometric training, a person can use their stretch reflex muscles to help them to perform better and more efficiently. If you're doing a power lift and you do a quick downward followed by an upward movement with your legs, you get more power in your lift. If you bend your legs slowly, then the power dissipates into heat and you have a less effective lift. According to the numerical model, Aaron's main weakness is in his jump height. Charlie is an inexperienced basketball player, yet his jumping is better than Aaron's. Charlie jumped higher on the 45-degree, 90-degree and counter-movement jumps. In order to improve his jump, and therefore his rebounding in basketball, Aaron needs to incorporate plyometric exercises into his training program on a regular weekly basis. For example, he could do 10 box jumps at a challenging height at the end of every training session for the next 3 months. This would also help his leg strength, which would improve his power. He could also add a variety by doing lunge jumps and squat jumps. These drills meet the SMART targets because they are specific. They target improving the power of his legs, which is the component of fitness, which will help to improve his jump height. Measurable. Aaron's jump height can be measured again in 3 months, 3 months' time, to see if he has improved. Achievable. Improving Aaron's jump height is achievable because Aaron is already a capable basketball player who has the potential to improve further. Realistic. Improving his jump is realistic because these exercises will give him more power to his legs, which will allow him to jump higher. Time-bound. Aaron is already doing training sessions, and these exercises are time-bound to the end of the sessions, so he will not forget to do them. He will be doing them for 3 months, and then his jump will be retested. Knowing that he is aiming at a 3-month test will help to motivate Aaron to do the drill.